that 6 minus x must be greater than or equal to 0, which means negative x plus 6 greater than or equal to 0, multiplied by negative 1, x minus 6 less than or equal to 0, or x less than or equal to 6. So the domain of this function is this. Is this acceptable?
Yes.
Perfect. That's my starting point. I have no choice. That's the domain. Negative infinity to 6. Okay. So obviously I will try to identify the x and y intercepts, and now I see if I plug in 6 I get 0. Also if I plug in 0 I get 0. That's not the correct 0. This should be in the function, not the derivative. Okay. Actually you're going to see what happens at 6. So the other thing that I need to determine, I found the x and y intercepts. I need to determine this limit. So when x approaches negative infinity, this goes to infinity and this goes to negative infinity. So limit as x approaches infinity from x to the square root of 6 minus x. This piece goes to infinity, and this one goes to negative infinity. So then the answer is negative infinity. And we cannot find anything else about the function from the function itself. That's done. Now we can move on to the first derivative. So f prime of x, it's a product. First function prime is 1 times the second function plus the first one times the second one prime, which is this, times the inner function prime. So I have the square root of 6 minus x and minus x over 2 the square root of 6 minus x. And now I have to find the least common denominator, which is this. So 2 the square root of 6 minus x, and this needs to be multiplied by 2 the square root of 6 minus x. Therefore, I have 2 6 minus x, or 12 minus 2x minus x over 2 the square root of 6 minus x, or negative 3x minus 12 over 2 the square root of 6 minus x. And yes, of course, negative 3x minus 4 over 2 the square root of 6 minus x. Let me check. What did I forget now? I hope nothing. That is correct. 12 minus 2x minus negative 3x minus 12. Okay. Then I see two things here, two critical numbers. X equals 6 is a critical number because the function is undefined, f prime being undefined. And from f prime of x being 0, I get x equals 4, which is another critical number. So, the first derivative and the second derivative do not exist at 6. And at 4, the first derivative is 0. Okay, so now I have to study the sign. I'm not going to use anything here. This is always positive. So negative x plus 4. To the left-hand side of 4, that will be positive, right? Because this is negative x plus 4. So to the left-hand side, anything I plug into the left will be positive. And anything I plug into the right, like 5, it's going to be negative. I need to plug in 4 in the function. 6 minus 4 is 2, the square root of 2, so 4 the square root of 2. Let me approximate it already. So 4 the square root of 2, so 4 times 1.2. I get something like approximately 5. Okay, so now I have to stop for a moment and make sure that these two rows go well together. From negative infinity to 0 and to 5, yes, increasing. And from 5 to 0, yes, decreasing, and that's supported by the sign of the first derivative. Obviously, 4 comma approximately 5 is a local max. Our next step is the second derivative, and then we're done. Where's my first derivative? Ugly, ugly, ugly. So my first derivative is negative 3/2 times x minus 4 over the square root of 6 minus x. I'm not going to involve the constant. I want it out. So the second derivative is negative 3/2. And I square the denominator, I get 6 minus x. When I differentiate the numerator, I get 1 times the square root of 6 minus x. Then minus x minus 4 times the denominator prime, 1 over 2 the square root of 6 minus x, times the inner function prime, negative 1. Maybe it's doable. Let's see. I would put this out. And let's see what we have in parentheses, because I also have the least common denominator. So let me write it first. Plus x minus 4 over 2 the square root of 6 minus x. And then I'm going to twist this around and just write plus 2 x minus 6. And then the least common denominator again is 2 the square root of 6 minus x. And this gets it 2 the square root of 6 minus x. So this is 2 6 minus x again plus x minus 4. So 3 divided by 4, x minus 6, and then the square root of 6 minus x, 12 minus 2x plus x minus 4. Okay, finally, 3 over 4 x minus 6, and what is this? Negative x plus 8. Over the square root of 6 minus x, and when I set the second derivative equal to 0, I get x equals 8, not in the domain. So no inflection point. 8 is not in the domain. So, but I need to study the sign of this. This is positive because the domain is negative infinity to 6. When I factor out the negative 1, so this is also positive, 6 minus x, with that minus x minus 8. So to the right hand side of 8, this is positive, to the left hand side is negative. So the function appears to be always, and it makes sense. It has to be, because this is a local max. Otherwise, this will not be a local max. Okay, finally, 1 more minute, so let's graph it. That's 6, and the function is 0 at 6. At 4, local max. So at 4, it has a local max, which is roughly 5. And at 0 is 0. The function is always increasing. It's coming from negative infinity, crosses the origin, it's always opening down, gets to the maximum, and then it not crosses, but it has a x-intercept at 6, 0. So here it is. So this is the function f of x equals x, the square root of 6 minus x.